Janna Levin, and I'm a professor of physics and astronomy at Barnard College and Columbia University, and I primarily study astrophysics. And astrophysics is really very much rooted in physics, the study of physical laws and how mathematics actually describes natural phenomena and laws, but it's applied to the universe as a whole, not just the things in it, stars, galaxies, the things that we observe at very great distances, but also space itself, space and time, and how space-time evolved, and even how the universe began and was created. So astrophysics is this very beautiful setting in which to study physics, in which to study the fundamental natural laws. In physics, there's kind of a distinction in people who work in physics between experimentalists, observers, and theorists. Experimentalists build things to try to make detections, to confirm and gather evidence. Observers will often use things like telescopes to look out into the sky and hopefully receive something from the cosmos that's new and never been seen before. And then there's theorists, such as myself, who often sit quietly with a pen and paper, maybe a computer, and use the mathematics to try to make discoveries, to talk to the observers, and maybe make suggestions for what they could look for. And then there are people who do all three and can combine all those skills. But there's a real conversation between doing the math, making a prediction, going to the observers to make an actual observation, or building an experiment, and vice versa. Sometimes there are discoveries made with telescopes that we just didn't foresee, and then we have to go back to our pen and paper, back to the drawing board, and figure out what did we miss and how could we not have predicted this phenomenon. And often it goes that way, that we're trying to understand something we've seen in the world but don't yet understand. So astrophysics draws from a lot of different kinds of study. And I actually came to realize that this was this beautiful field kind of late. I was not interested in physics when I was a student. I was not one of those kids in the basement with the chemistry lab, and I didn't understand or appreciate how elegant and beautiful science was until much later. I wouldn't say I had a fear of mathematics, but I didn't recognize how rich and beautiful it was. And it wasn't until later when I understood that mathematics gives us this kind of, it's a gift that connects us to the natural world, that somehow through mathematics we're able to understand natural phenomena. And then that's just remarkable. And that it's the same wherever you are in the world, and it's the same at the other side of the universe. 1 + 1 is still 2. So there's something that connects all of us there that seems really important. And when I discovered that in college, I became completely enamored of physics and math and astronomy, and I started to study astrophysics. And now I work on questions like how did the universe begin, and how is it evolving, and how many dimensions are there? Are there more than 3 dimensions in the universe? And what's the universe made of? Because the most important questions right now seem to be bound to an attempt to understand what the universe is made of, because we've realized that most of the universe is in a form of matter and energy that we've never seen before, because it's literally dark. We cannot see it with our telescopes, but we know it's out there because we can see the effect it has on galaxies and on the expansion of the universe. And so we deduce that this energy is out there and this matter is out there. But amazingly, it is nothing like any kind of matter or energy we've ever seen before. And so it's this very big question that says, by studying astrophysics, we're learning about the deepest underlying principles in nature that are fundamental to how the universe began and evolved.